Hello there. Here's a gem of a problem where given 3 points, and they do have to be non-collinear points, we get exactly one circle. This is a rather involved problem, so I don't know if we're going to be able to get it all in this little screen here, so it'll be kind of challenging. But it has us practice all of the basics from the first lesson. So let's give it a shot, graph the 3 points. Okay, without loss of generality, I'm going to call them A, B, and C. The A is going up pretty high, but I can still use it there. First thing I'm going to do is find midpoints for the lines connecting AB and BC. We could also do AC, but then it winds up overlapping, so I'm going to do these exterior too. Okay, we're going to call that point D and it's the midpoint of AB and get its coordinates. Okay, not the prettiest coordinates, but there we go. It's at 1/2, so I have it shift over, it looks like 1, but it's actually at 1/2 and 11.5. And I could make that 23 halves if I need to work with it later on. Instead of going straight ahead and figuring out the midpoint of BC, I'm actually going to continue to work with this point D, and I'm going to get the perpendicular bisector here. But to do that first, I need the slope of this line AB. So as I move from A to B, I'm going from 12 down to 11, so it's down 1, -1 to 2 over 3. My slope is -1/3. So this perpendicular line here, it needs to have a slope of 3. Okay, we'll call this line 1. I know that the slope of line 1 is 3. I also know it goes through the point up here, 1/2, 11 halves. So I'm going to put all that information in point slope form and get the equation. Distribute the 3 across, and then add that 11.5 to the other side. Alright, there's the equation of line 1. The slope is 3. Y-intercept should be up here at 10. Looks like my picture is off a little bit. If we were doing this on graph paper with paper and pencil, this would be easier to do. But it's not the most terrible looking thing. I'm trusting my algebra anyways. So let's go over here to BC, get that midpoint. Okay, then I will look at the slopes. We're going down 8 over 6. And that reduces to -4/3, so the slope of the perpendicular bisector will be +3/4. And since I know a point on that line, 5, 7, and I know the slope of that line, I'll put it into point slope form. Distribute across, and convert 7 into fourths to add to the other side. Okay, now we want to know where the blue line and the green line intersect. It's looking like it might be at -3,1, but I'm going to trust the algebra skills, so I'm going to set those lines equal to each other. It looks like I also ran out of space, so I am going to scroll out a bit. Yucky, yucky fractions, so I'm going to multiply by 4, and then gather my like terms. And finish it up. Okay, so our graph was actually pretty decent this time. They did intersect back there at -3,1, so that's going to be the center of the circle, and then the original 3 points A, B, and C, they should all be the same distance from this one, and I want to know what that distance is. Not D and E, they're going to be on the inside of the circle. Okay, I'll set up a bit of a distance formula here from -3,1 over to 8,3. I could also frame the shape. I'm going over 11 up to square both of those, 121 plus 4. So the distance squared is 125. If I wanted just the distance, I could clean that up into 5√5, but this 125 is going to work nicely. I'm just going to double check for sure, make sure that B and A are the same distance there. Okay, that one's also looking good, and from here, O to A, that's also going over 2 and up 11, so it's the same kind of triangle that OC was. So I have all the information I need at this point. I know where the center of that circle is, -3,1. I also know what the radius is. It's the square root of 125, and I can write the equation. And remember, when you're doing this, it's going to be x minus the x coordinate. So x minus the -3 becomes x plus 3, quantity squared. and y minus the y coordinate for the center, so y minus 1 quantity squared equals the radius squared. My radius in this case, I'll denote that on the side here. My radius in this case was the square root of 125, or 5 root 5, but I worked with it in that radius squared form, so I just write 125 over here. Fairly long kind of problem, but it practices all of our basics because we need to be able to calculate midpoints, get slopes, get perpendicular, slopes of perpendicular lines, write the equation of a line given a point and the slope, figuring out the intersection of a line, that's all stuff from our first unit, and then we have distance formula and equations of a circles. So this little problem's got it all. Please practice it, master it. Character and scholarship for life.